Hi everyone, in today's presentation we will be covering chapter 4.2, multiplying and dividing fractions from the OpenStax Pre-Algebra textbook. Our core learning objectives then in this lesson are to learn how to simplify fractions, multiply fractions, find the reciprocals of fractions, and then also divide fractions. So let's go ahead and get started with this initial introduction question that asks us to define the meaning of simplifying a fraction. So what does it actually mean? And then also, how might we simplify the fraction 4/8? So I'd go ahead and pause the video and answer these two questions before moving forward. All right, so coming to the question, simplifying a fraction. Simplifying or reducing fractions means to make the fractions as small as possible. So for example, it's taking 4/8 and then bringing it down to its smallest terms, 1/2. Now notice here that 4/8 and 1/2, these are equivalent fractions. They are the same value. It's just we've taken out some of the divisions that you have from the first 4/8 circle to the 1/2 circle here. Now, how we basically simplified is we have divided by a common factor between each of these. So if I start with 4/8, a common factor between 4 and 8 is the factor 2 and 2. This gets us then to 2/4, and if I go by another 2 and 2, this gets us to 1/2 here. Now you can also, instead of doing it in chunks, 2 and 2, we could, in fact, go by a greatest common factor, the largest number that divides into both numbers, which is the number 4 here. So 4 divided by 4 is equal to 1, and 8 divided by 4, cut off the 4 there a little bit, is equal to 2 here. Okay, so 1/2 is, again, our most simplified form here. Now let's go ahead and look at simplifying fractions, a question series. So we are going to go ahead and simplify 3/9, 30 over 45, and 24 over 108. Now to do this, we are going to use the steps from the textbook, which is step number 1, rewriting the numerator and denominator to show the common factors. If needed, we can factor the numerator and denominator into prime numbers. Step 2, we will simplify using the equivalent fractions property by removing common factors. Essentially, that's the dividing principle. And then step 3, multiply any remaining factors here. So starting with question number 1 then, we have 3/9. And then if I follow the first step, we rewrite the numerator and the denominator to show the common factors. So 3 really can be written as 1 times 3, essentially. And then 9 can be written as 1 times 3 times 3. So if I look at the common factor, in other words, the number that you would divide away from the 3 and the 9, that would be that common factor of 3. And then what you then have is 1 by itself in the numerator, and then 1 times 3, which is 3 in the denominator. So our answer for this would be 1/3. Now you could also simply just structure or make it look like this, where you are dividing that common factor of 3 into both top and bottom parts of your fraction. But this is the structure when you view the textbook on how they actually show how to simplify those fractions here. So let's look at question number 2 now, which is 30 over 45. So if I look at restructuring for common factors, we might see that 30 and 45 have a couple common factors. In fact, if I was to change these to prime numbers, 30 can be rewritten as 3 times 2 times 5. Could write that, I guess, from smallest to largest. So 2 times 3 times 5. So 3 times 2 is 6, 6 times 5 is 30, or you could say 2 times 5 is 10, and the 3. And then 45 can be written as 3 times 3, which is 9, times 5 at the end. Now, if you look at your common factors here, we have 3 and 3, and 5 and 5. And what's 3 times 5? Well, it's 15. So 15 is actually the biggest number that divides into each of these numbers evenly. So if I cancel out the common factors, we have 3 and 3 can cancel out. I can't cancel out this 2 and that 3. They're unique, but I can cancel out 5 and 5. So essentially, the numbers I'm left with then are 2 and 3 here. So 30 over 45 reduces down to 2/3. Now, if you wanted to show it more just with a straight division structure, we could write this where we take the biggest common factor that we just now see, which is 3 and 5, and we divide both the top and the bottom by 15 here. And what we end up getting is 2 and 3. All right, let's look at question number 3 now. Now, question 3, the numbers are a little bigger, so it's a little harder initially to just decide what factors there are. So what I would recommend doing this for this one is to first do the prime factorization of both 24 and 108, and then rewrite the numerator and denominator as the prime factors here. So 24 can be reduced down to 2 and 12. 12 is a prime number. 12 can be reduced down to 2 and 6, another prime number. And 6 can be reduced down to 2 and 3 here. 2 more prime numbers. 108 then can be reduced down to 2 and 54. 54 can be further reduced down to 2 and 27. 27 can be reduced to 3 and 9. And then 9 can be reduced down to 3 and 3. So 108 definitely has a much longer prime number list, right, of those prime factors. Again, the biggest reason we're doing this is every number has basic building blocks. Those are your prime numbers. And this skill can be very useful as you start to go into more advanced mathematics, algebra, for example, where you might be factoring out expressions like trinomial expressions, quadratics, etc., etc. So 24 over 108, if I was to then rewrite this as the product of its factors, 24 can be written as 2 times 2 times 2 times 3. And then 108 is going to be 2 times 2 times 3 times 3 times 3. So let's now wipe out the common ones. So we can eliminate 2 and 2. This 2 and 2. This 2 is now not covered, so this has to stay, but you can reduce down this 3 and this 3. So what we now have here is we have a 2 in the numerator, and we have 3 times 3 in the denominator, and that is our answer, 2/9. Now, if I'm dividing the greatest common factor for 24 and 108, that would be me multiplying the 3 factors I crossed out. 2 times 2 is 4, 4 times 3 is 12, right? So if I had, let me rewrite this, 24 over 108, and I divided the greatest common factor, which is 12, into both the top and the bottom numbers, we would get back to where we are. So 24 divided by 12 is 2, and 108 divided by 12 is going to be 9 here. Okay, so 2 over 9 is our result. All right, so that's simplifying fractions. Now let's add some variables to fractions that we're asked to simplify. So the same steps, but now we have some extra variables as part of the product here. So we have 5xy over 15x. Now what we can do is we can rewrite the numerator and the denominator to show the common factors. So 5xy, really, we're actually going to keep that exactly the same, really. Now I'll show this out as its own individual factors though. So 5 times x times y. And 15 then can be written as 3 times 5. So 3 times 5 is 15 times x. So now if I look at the common factors here, I see that we have a 5 and a 5 that can cross out, and we have an x and an x that can be eliminated. So what we now have in the numerator is y, which also you could have this as 1y, but we'll put as y in the numerator. And then we have 3, that's by itself in the denominator here. So y over 3. So what we really divided by in both the numerator and the denominator here is we divided by a factor of 5x. So the greatest common factor for this is 5x as a factor. How? Well, again, 5 times x here. That's what we eliminated out. So again, the y is now by itself, and the 15 divided by 5 is 3, and then the x's eliminate, so we just have the y over 3. Looking at question number 2 now, we have 10x y over 20x. So let's rewrite to show the common factors. So 10xy over 20x. The 10x, or the 10, I guess, can be written as 2 times 5 times x times y. The 20 then can be written as 2 times 2 times 5, right? 2 times 2 is 4, 4 times 5 is 20, times x. Then the numbers that we can eliminate is one of the 2's and the 5. And for the variable, the x. So now what we end up having at the end is we have, again, y in the numerator here. And in the denominator, we have a 2 by itself. So our answer for this becomes y over 2 at the end. Now we're moving into multiplication of fractions, and we're first going to start with modeling a fraction using a diagram. So let's look at the fractions 1/2 times 3 over 4. And we're going to start with the bigger fraction and visualize what that looks like. So 3/4 of a fraction looks like this. We have 4 divisions of a rectangle, and we have filled in 3 of these 4 pieces of the rectangle. Then we're going to take the 1/2, and when we multiply it by 3/4, it's almost essentially similar to dividing of whole numbers, right? When we multiply by a fraction, it's very similar to that principle. So we're going to put then a division mark through this grouping, and we now have 8 total divisions here. Or reading the step, we will take 1/2 of this 3/4, so we heavily shade 1/2 of the shaded region here. Now, looking at what our overall answer is, we have 8 divisions, and the heavily shaded part of this includes 3 different pieces here. Now, essentially what you're doing with this is you are multiplying your numerator, so that's 1 times 3, which is 3, and you are multiplying your denominator, which is 2 times 4, or 8 here. So your answer at the end is 3/8. Now let's multiply the following fractions. So starting with question number 1 here, we have 4/5 times 1 over 4. So rewriting this, 4/5 times 1 over 4. Let's now utilize the following steps here. So step 1, we will simplify by cross-reducing. So my recommended first step when you're working with fractions is to reduce to start. The reason we can do this is, or the reason we want to do this, is it keeps the numbers smaller, right? So when you work with smaller numbers, you are less likely to make errors in calculation. So looking diagonally, we realize that we can reduce the 4s, right? So I can divide this by 4, and I can divide this by 4. So rewriting my new fractions, I have 4 divided by 4, which is 1. I can't divide 1 and 5, so we just write 5 now, times 1 over 4 divided by 4 is 1. So this is step number 1 that's been completed. Step number 2 is to now multiply your numerators. So we will multiply 1 times 1, which is 1. And then multiply our denominators, which is 5 times 1, or 5. So 1/5 is our result. We can then ask ourselves, can we simplify further, or can we convert to a mixed fraction perhaps, if it was an improper fraction? Now, since I simplified as far as I can go at the beginning, most of the time you will not have to simplify any further at the end. That's the case here. So 1/5 is a proper fraction. It's also simplified to lowest terms. So 1/5 is our result. Now let's go ahead and look at question 2. So we have 1/2 times 6 over 8 here. My first step is to simplify by cross-reducing, which I can do. I can reduce the 2 and the 6. I cannot reduce the 1 and the 8. So I'm going to divide a 2 into 2 and a 2 into the 6. Rewriting my fractions, I now have 1 in the numerator. 2 divided by 2 is also 1, times 6 divided by 2 is 3, and I have 8. Now I can multiply 1 times 3. So I've completed step number 1. Step number 2, multiply my numerators. 1 times 3 is 3. Step number 3 then is to multiply my denominators. 1 times 8, which is 8. And then I can simplify if necessary, or convert to a mixed fraction if this was improper. Well, 3/8 is as far as we can go. There is not a common factor that you can divide into 3 and 8. So this is also a proper fraction, cannot convert it to a mixed fraction. So this is my answer right here, 3/8. Looking at question number 3 now, we have 2 over 3 times 9 over 12. Now in this case, there is an ability to reduce both ways. So I can reduce the 2 and 12 by a factor of 2. So 2 divided by 2 and 12 divided by 2. And then 3 divided by 3 and 9 divided by 3. So now rewriting this, I have 2 divided by 2 is 1. 3 divided by 3 is also 1, times 9 divided by 3 is 3, and 12 divided by 2 is 6. Okay. Step 2, multiply my numerators. 1 times 3 is 3. Step 3, multiply my denominators. 1 times 6 is 6. And now I have 3 over 6. Now this is a fraction that I can actually reduce, so 3/6 can be reduced further. The reason for that is really 9/12 could have been reduced at the beginning if I wanted to reduce that fraction. That's why I have to reduce at the end here. So I am now going to divide a common factor into both 3 and 6, which in this case is a common factor of 3, right? So 6 could actually, if I did the equivalent fractions, this would be 2 times 3, and 3 is just 1 times 3, so the common factor being 3. That's where I get the division mark. So 3 divided by 3 then is equal to 1. 6 divided by 3 is then equal to 2 here. Okay, so my answer is going to be 1/2. Now let's multiply some fractions that include improper fractions within the mathematical statement. So starting with question number 1, we have 9/6 and we have 2/5. So we'll go ahead and write that, 9/6 times 2/5. My step-by-step process for improper fractions are the same as previously. So I'm going to look diagonally, crosswise, and see if there is a number that I can divide into both. So 9 and 5, there's not a common factor, right? 9, the only factors of 9 are 1, 3, and 9. The only factors of 5 are 1 and 5. 2 and 6, though, can be. Common factor here is a 2. So I'm going to simplify the 2 by 2, so 2 divided by 2, and the 6 divided by 2. So now, rewriting the fractions, we have 9/3 times 1/5, right? 2 divided by 2 is 1. Next, we will multiply our numerators. 9 times 1 is 9. And we can multiply our denominators. 3 times 5 is 15. So now I have 9/15. Now 9/15 is another fraction that can be reduced, right? So the factors of 9 are 1, 3, and 9. I'll go ahead and write that actually like previously. So if I wrote the common factors of 9, this is 1 times 3 times 3 if I wrote it with a 1. I don't really actually need to write the 1 technically, but I did anyway. And then 15 is going to be 1, 3, and 5. So the common factors here then between these two are the 3 and 3 essentially, right? So in other words, I have 1 times 3 and 1 times 5 as being my answers here. Okay, so then if I multiply these two, 1 times 3 is 3, 1 times 5 is 5. So 3/5 is my result. Now if I wanted to show it out with the division kind of model, we are dividing basically by a common factor of 3 on both the top and the bottom parts of the fraction. 9 divided by 3 is 3. 15 divided by 3 is 5, right? So kind of two different structures, ways of viewing it, but both equally valid. Okay, so looking at question number 2 now, we have 8/3 times our 7/4 here. Okay, so let's look and see if we can cross reduce here. In this case, we can. Just one way though. I can only reduce the 8 and the 4. So the greatest common factor for 4 and 8 is the number 4. So I can divide the 4 into 4 and the 4 into the 8 here. Rewriting this, 8 divided by 4 is 2 over 3 times 7/1 here. So now I have 2/3 times 7/1. I've done step number 1. Now let's go ahead and multiply my numerators. 2 times 7 is 14. Multiply my denominators. 3 times 1 is 3. And then I can simplify if necessary. Now 14/3 does not have a common factor. However, notice that this is an improper fraction, so we can change this to a mixed fraction. I'm going to go ahead and use a long division model to do this. So I ask, okay, how many times does 3 go into 14? Well, 3 goes into 14 4 times. 4 times 3 is 12. 14 minus 12 is 2. The 2 becomes the new numerator, and the denominator stays 3. So in other words, 14 over 3 converts to a mixed fraction of 4 2/3. So depending if the question asks you to convert from improper fractions to mixed fractions, this is how you would do so. Okay, so looking at question number 3 now, we have 15 over 2 times 20 over 3 here. Okay, so we are going to look to see if we can cross-reduce first, which we can. We can actually go both ways. So I can divide a 2 into the 2 and a 2 into the 20. And we can divide a 3 into the 3 and a 3 into the 15. So then rewriting this, we now have 15 divided by 3, which is 5, and 2 divided by 2, which is 1, times 20 divided by 2, which is 10, and 3 divided by 3, which is 1. Now we can multiply across, so multiply our numerator, step number 2, which is 50, and multiply our denominators, which is 1 times 1, which is 1. 50 divided by 1 then is equal to 50. So I can simplify that down to a regular whole number. All right, so that is multiplying fractions. Next, we're going to start moving into dividing of fractions, but before we get there, we will need to define the meaning of a reciprocal. So we're going to find the reciprocal of the following fractional numbers here: 5/9, -2/3, and 8. Now the definition of a reciprocal is the following: A over B is equal to B over A. This is really just a fancy way of saying flip the number or the fraction over. You're making the number that's in the numerator now in the denominator, and the number that was in the denominator to start now in the numerator. So 5 over 9 then, the reciprocal of this is going to be 9 over 5. Now I know it's the reciprocal if I were to multiply the two fractions and my answer becomes 1. If it is that, then that's the reciprocal. So 5 times 9 is 45. And 9 times 5, or 5 times 9 is 45, and 9 times 5 is 45. And 45 divided by 45 is equal to 1. So that meets the definition of your reciprocal. Question number 2 then, -2 over 3. The reciprocal of -2 over 3 is still negative, so you keep the negative when it's a negative, and it becomes -3 over 2. Okay, so that's the reciprocal of question number 2. Question number 3, a little interesting. You might say, Chris, hey, I don't see a number under 8. How do I actually find the reciprocal? Well, remember, every whole number, you can put a 1 under it, right? So 8 over 8 can become 8 over 1, which then you're able to flip this, able to find the reciprocal. So 8 over 1 becomes 1 over 8 here. And that is your reciprocal. Okay, so now let's go ahead and work on some division of fraction problems. So let's start with 3 over 4 divided by 1/2. Now I have a process, an algorithm here that we can use to work with fractions. So this is one way of doing it. You can also visualize fractions as well to help you solve. But this process then uses step number 1, which is more of a mnemonic, really a shortcut kind of understanding of what to do here, where we are going to keep the left side fraction. We're going to change the division symbol to multiplication, and then we're going to flip or find the reciprocal of the right fraction. Keep it, change it, flip it. So 3 over 4 stays 3 over 4. We keep it. Division changes to multiplication. and 1 over 2 flips to 2 over 1. So from here then, I can follow the same exact steps I did for multiplication. I can ask myself, can I simplify by cross-reducing? Well, 3 and 1 cannot be, but 2 and 4 can be. I can divide a 2 into both 4 and 2 here. So my new fraction now would read 3, 4 divided by 2 is 2, times 2 divided by 2 is 1, over 1. That's step 2. Step 3 then, multiply my numerators. 3 times 1 is 3. Step 4, multiply my denominators. 2 times 1 is 2. And then simplify if necessary. Well, 3 over 2 cannot be simplified, but it can be converted to a mixed fraction. So 3 over 2 can become 1. 2 goes into 3 one time. 1 times 2 is 2. 3 minus 2 is 1. That is the remainder. And half is the fraction next to it. So 3 over 2 converts or changes to 1 and a half. Let's look at question number 2 now. We have 5 over 6 divided by 2 over 3. I'm going to keep the left side fraction, change the division to multiplication, and flip or find the reciprocal of 3 over 2. So key principle here, dividing by 2 over 3 is the same as multiplying by 3 over 2, the reciprocal of it. Kind of a key learning point there. Next, we're going to see if we can cross-reduce. 5 and 2 cannot be cross-reduced, but 3 and 6 can be. I can divide a 3 into the 3 and a 3 into the 6. Rewriting this, I now get 5 over 6 divided by 3 is 2 times 3 divided by 3 is 1 over 2. So now I have 5 over 2 times 1 over 2. I'm going to multiply my numerator. So let me check the steps off. So step number 3, multiply our numerators. 5 times 1 is 5. Step 4, multiply our denominators. 2 times 2, which is 4. Step 5, simplify if necessary. Well, 5 over 4 cannot be simplified down. There is not a common factor that you can divide into 5 and 4. However, you can convert this to a mixed fraction. Let me actually go ahead and do the long division. I kind of did it in our head for the last problem. So let's confirm with long division. 4 goes into 5 one time. 1 times 4 is 4. 5 minus 4 is 1. That is a remainder. That goes in the top part of the fraction. And our denominator is 4, and it stays 4 at the end. So 5 over 4 converts or changes to 1 and 1/4 here. So now looking at question number 3, we have 7 over 8 divided by 3 over 4. We will keep the left side fraction. We will change division to multiplication, and we will flip 3 over 4 to become 4 over 3. Then we will cross-reduce. 7 and 3 cannot be cross-reduced. 4 and 8 can be. I can divide a 4 into the 4 and a 4 into the 8. So rewriting this, I now have 7, 8 divided by 4 is 2, times 4 divided by 4 is 1, over 3 here, okay? Now I can go to step number 3, multiply my numerators. 7 times 1 is 7. Multiply my denominators. 2 times 3 is 6. 7 over 6 is now my fraction. I cannot simplify this. There's not a number that divides evenly into 6 and 7. However, 7, the top number, is bigger than 6, the bottom number. That's an improper fraction. And I can convert to a mixed fraction by asking myself, how many times can I divide 6 into 7? Or how many times can I go into 7? That's one time. 1 times 6 is 6, or is 6. 7 minus 6 is 1. The 1 is the remainder. That becomes the new numerator, and 6 stays the denominator. So this kind of got scrunched. So just to make sure that you know what this is, 7 over 6 becomes 1 and 1/6 in terms of a mixed fraction here. Okay, so that's question 3. The final question series here is a continuation of dividing of fractions, but now we have included some improper fractions in the questions here. So starting with our first question number 1, we have 3 over 5 divided by 7 over 4. Okay, so let's go ahead and keep it, change it, flip it now. So 3 over 5 stays 3/5. That's the keep it part. Division changes to multiplication, and the 7 over 4 changes to 4 over 7 here. Okay. All right. Next, let's simplify by cross reducing. 3 and 7 cannot be reduced down. 4 and 5 cannot be reduced down either. So this is a unique one that we've come across where we can't actually simplify by cross reducing to start. So now let's go to step 3, which is to multiply our numerators. 3 times 4 is 12. And multiply our denominators. 5 times 7 is 35. So now we have 12 over 35. Can we simplify this? Well, the only factors of 35, I'll go ahead and do the common factors here. So let's say we have 35, which is 5 times 7, and 12 would be 3 times 4, for example, or 3 times 2 times 2 if I broke to prime numbers. None of these are common factors, right? There are no common factors here. So in other words, 12 over 35 is as simplified as we can go. It's also not an improper fraction, right? The top number, 12, is smaller than the bottom number, 35. So can't reduce that any further. Okay, so that's question number 1 in this question series. Going into question number 2 now, we have, give me a pen. We have 9 over 4 divided by 2 over 3. So let's keep it, change it, flip it. 9 over 4 stays 9 over 4. Division changes to multiplication. And the right side fraction flips over to 3 over 2 here. Step number 2, can we simplify this one? Can we simplify by cross reducing? Well, 9 and 2, nope, not a common factor. 3 and 4, not a common factor. So for this one, we can't cross reduce like the previous one. Step 3 then, multiply our numerators. 9 times 3 is 27. Step 4, multiply our denominators. 4 times 8 is 8. I now have 27 over 8. So if I see if I can simplify this, the common factors then, or the factors of 27, I should say, we have 3 times 9, which if I wrote as prime factors, let me go ahead and write as prime factors. This would be 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 8 then is 2 times 2 is 4 times another 2 is 8. There are no common prime numbers, right? No common factors. So I can't reduce that down at all. 27 over 8 though, let me give myself some room. I'm going to go over here. 27 over 8 is an improper fraction though. The top number 27 is bigger than the bottom number 8, which means we can change to a mixed fraction. So 8 goes into 27 3 times. 3 times 8 is 24. 27 minus 24 is 3. 3 is the remainder. That becomes the new numerator. And 8 stays your denominator. So in other words, 27 over 8 becomes 3 and 3/8 as your result. Okay, so let's look at the final question in this question series now, which is going to be 11 over 6 divided by 5 over 8. Okay, so looking at our step number 1, keep it, change it, flip it, we can keep 11 over 6. We can change the division sign to multiplication, and we can flip the right side fraction to 8 over 5. Next, let's look to see if we can simplify by cross-reducing. Well, 5 and 11 you cannot cross-reduce, but 8 and 6 you can. A common factor of 8 and 6 is the even number 2. So I'm going to divide a 2 into the 6 and a 2 into the 8. Rewriting my fractions, I now have 11 over 3 times 8 divided by 2 is 4 over 5 here. So my final step now is to multiply my numerators. 11 times 4 is 44. And multiply my denominators. 3 times 5 is 15. Now, I can then ask, can I simplify this further? Well, 44 and 15 do not have any common factors, but it is an improper fraction, so I'll give myself some room over here, and we will convert this into a mixed fraction. So the multiples of 15 are 15, 30, 45. That's too much. So it goes in twice, right? 15 times 2 is 30. So 2 times 15 is 30. 44 minus 30 is 14. 14 becomes the new numerator. And our denominator stays 15 here. So 44 over 15 changes to the mixed fraction 2 and 14/15. Okay. So this concludes our presentation. Again, our core learning objectives for chapter 4.2, multiplying and dividing fractions, were to simplify fractions, multiply fractions, find reciprocals, and divide fractions. I will link the free textbook to OpenStax within the description of the video. So feel free to do some extra problems, and also feel free to put some questions in the comments if you have them. All right, everyone, good luck, and I'll talk to you in the next video.